All right, the objective of this video, students will find areas of trapezoids, rhombi, and kites. So first of all, a little definition here. What is the height of a trapezoid? Height of the trapezoid is a perpendicular segment between the two bases. So if I want to find the area of a trapezoid, the formula is 1/2 the height times base 1 plus base 2. So I'm wondering, does that look familiar? Does that remind you of anything? Well, deep in the recesses of your brain, we learned about the midsegment earlier this year. The midsegment was equal to half of base 1 plus base 2. So another way that you can find the area is to do the midsegment times the height. In essence, what you're doing is you're averaging your bases, and then you're just multiplying it times the height. All right then, to find the area of a rhombus, it's 1/2 of diagonal 1 times diagonal 2, or if you prefer, you can do diagonal 1 times diagonal 2 over 2, if that's easier for you to do it that way. And the same is true for the area of a kite. It's 1/2 diagonal 1 times diagonal 2. So in example 1, we're going to find the area of these trapezoids. So let's start with this one up here first. Okay. All right, so we're going to find the area of the trapezoid. So first of all, I know the area is 1/2 the height times base 1 plus base 2. So I need to figure out which numbers I need. Well, my bases are here, 16 and 8, and my height is 8√2. And these 12 feet on the sides don't give me any information that I need, so just ignore that. So let's go through now and plug in what I know. So half of the height, so 1/2 times 8√2 times base 1 plus base 2, so 8 plus 16. And then you just simplify. Half of 8√2 would be 4√2. And 8 plus 16 is 24. And so then the area would equal 96√2 square feet. Because 4 times 24 is 96. All right, so now here's your chance to do one. Find the area of this trapezoid. Go ahead and hit pause. All right, so the height was 4 and the bases were 7 and 9, and when you put it into the equation, you should end up with the area equaling 32 square feet. All right, so now we're going to find the area of these two rhombi. So you'll recall that the area of a rhombus is 1/2 diagonal 1 times diagonal 2. So I need to figure out my diagonals. What they've done is they've given me half of the diagonal here. So diagonal 1 is actually going to be 2 times 8, or 16. And then same thing here, they've only given me half of the diagonal. So diagonal 2 will be 11 times 2, or 22. And so the area is going to be 1/2 of 16 times 22. And that comes out to 176 centimeters squared. Okay, looking at example 2b, says the rhombus has sides equal to 15 units and the longer diagonal is 26 units. Find the area. So what we're going to have to do for this one is use the Pythagorean theorem to find the other diagonal. So let's go ahead and put in the information they gave us. The sides are 15 and the longer diagonal is 26 units. So that means that half of it is 13. And then I need to figure out how long the other one is. So x squared plus 13 squared is going to equal 15 squared. So we have x squared plus 169 equals 225. If I subtract 169 from both sides, I get that x squared is equal to 56. And so when I take the square root, x is going to be 2 root 14, or 2 root 14. We'll go ahead and leave it as a radical. All right, so now I have my other diagonal, almost. Don't forget that the diagonal, you have to double that. So it's going to be 4 root 14. So this length here is 4 root 14. So the area is going to be diagonal 1 times diagonal 2, so 4 root 14 times 26 divided by 2. And so that ends up coming out to 52 root 14 units squared, or square units. Looking at example 3, one diagonal of the kite is 2 times as long as the other diagonal. The area of the kite is 56.25 square inches. What are the lengths of the diagonals? So if one is twice as long, I can use x for my shorter diagonal and 2x for my longer diagonal. And I plug it into the formula. So area equals 1/2 diagonal 1 times diagonal 2. So they told me the area was 56.25, so I put that in for A, equals 1/2 times x times 2x. 56.25, half of 2 is 1, so we just end up with x squared. So then you just have to take the square root of both sides, and x comes out to 7.5 inches, and that means that the other diagonal is twice as much, or 15 inches. So the lengths of the diagonals then are 7.5 and 15 inches. All right, now it's your turn. We're going to find the area of the figures. So first find the area of the kite. Pause the video now. All right, so if you look at the graph, you can see that one diagonal is 4 units long, the vertical one, and the horizontal diagonal is 6 units long. And so the area is half of the two diagonals multiplied together, so 4 times 6 divided by 2. And so you should have gotten 12 units square. All right, now find the area of the trapezoid. Go ahead and pause the video now. Make sure that you notice that each of these is worth 3 units also when you're figuring out the area. All right, so from the graph you can determine that the height is 15 units, the base is 21 units, and the other base is 9 units. So the area is half of the height times base 1 plus base 2. So that's comes out to 225 square units. All right, now we're going to find the area of the shaded region. Now I see that they gave me the two bases, but I do not know my height. But they gave me an angle. So when you see an angle, chances are you're going to have to use sine, cosine, or tangent. So if we look at this one, if I make this into a triangle over here, call it x, that's going to give me the height of my trapezoid. So I have to first figure out this distance here, so I know what that side of that triangle is. So this down here, it's 14, just like up above, and so if I subtract 14 from 37, that means that the base of the triangle I created is 23. So I have the opposite and the adjacent, which means I'm going to use tangent. So the tangent of 42 is equal to the opposite over adjacent, so x over 23. I multiply both sides by 23, and I get that x is equal to 23 times the tangent of 42. And if you put that into your calculator, you should get approximately 20.7. Now what you can do is you can leave that in your calculator and go ahead and just divide it by 2, because the formula is 1/2 the height. So you take that 20.7 and divide it by 2, and then you multiply it times 14 plus 37. And you should get that the area comes out to 528 square units. Double check that you get the same thing when you put it in your calculator. Alright, and now we have a trapezoid with a rhombus cut out of the middle of it. So I just want to find the shaded area. That means essentially what I'm going to do is I'm going to take the area of the trapezoid and I'm going to subtract the area of the rhombus. So the area of the trapezoid is 1/2 the height, which is 10, and the sum of base 1 plus base 2, so 11 plus 15. 11 plus 15 is 26, so 1/2 times 10 times 26 comes out to 130 square units. Then I find the area of the rhombus, and it is half of the diagonals together multiplied. Well, I can figure out that this diagonal is 10, but how can I figure out the other diagonal? Well, I know that this line right here is exactly halfway between my bases, so it is my midsegment. So that means it just equals half of 11 plus 15, or half of 26, so it comes out to 13. So now I have both of my diagonals, so the area of the rhombus is half of 10 times 13, or 65 square units. So the shaded area is just 130 minus 65, and so it equals 65 square units. All right, so now I have a figure that is a kite and a square put together, but I don't have all the information I need, or at least it looks like I don't. I'm going to have to do some solving to figure out what the different pieces are. So you might want to just watch me do this and write it all down afterwards. I want you to be paying attention to what I'm doing. All right, so looking first at the top, at the kite on top. They told me that all of these sides are congruent to each other. So that means that if the side of the square is 6, this part of my kite is also 6. And I have essentially here, I have a 45, 45, 90 triangle right here. Because my two legs are congruent, so that means it's a 45, 45, 90. So I can figure out one diagonal because it's the hypotenuse of my 45, 45, 90. So my leg is equal to 6. That means that my hypotenuse is equal to 6 root 2. And so I know that this part now is 6 root 2. That's one of my diagonals. But I've got to find the other diagonal as well. So first of all, I notice I actually have a smaller 45, 45, 90 right here. Right here is a smaller 45, 45, 90. And the legs on that one are, well, this leg is half of 6 root 2, so it's 3 root 2. And that means that the other leg is also 3 root 2 because my legs are equal. So my first one, I found the 6 root 2, and then with my 45, 45, 90 again, my legs were equal to each other. And so the leg is 3 root 2. Alright, so now I have one more triangle that I need to figure out because I need to know this distance here for the rest of that diagonal. So if I look at this triangle, it's a right triangle, and so I can use the Pythagorean theorem. Alright, so I'm going to say then that x squared plus 3 root 2 squared is going to have to equal 10 squared. So 3 root 2 squared comes out to 18, and 10 squared is 100. So x squared is equal to 82, which means x is approximately 9.1. And my 3 root 2 is approximately 4.2. So if I add those together, the longer diagonal, 9.1 plus 4.2, comes out to 13.3. And then my shorter diagonal, so I'll call that one diagonal 1, diagonal 2, we found up above, was 6 root 2. And if you put that in your calculator, it's approximately 8.5. And so now I can determine the area of the kite. It's going to be half of the 13.3 times 8.5, and that comes out to 56.5. And then we also have to add our square onto that, so the area of the square is just 6 squared, or 36. And so the total area is is just 56.5 plus 36, so it comes out to 92.5 square units. And that concludes this video. Thank you.